In 1973, the United States added the northern Rocky Mountain gray wolf to the list of endangered species.
This allowed scientists to begin developing a recovery program.
Bringing a species back from the brink of extinction to a healthy population, it requires a lot of science and a lot of planning.
Not to mention the long monitoring period to make sure that the plan is being followed and that it works.
Scientists try to determine what factors affect population and collect data about those assumptions.
They then make hypotheses based on this data to show what the population would be like under certain circumstances.
Now, we can do the same thing. Let's assume that there are 4 factors involved, and that the first 2 factors deal with the number of litters of the average female wolf.
Now, the next one is the average number of pups in each litter. Half of these pups are assumed to be female.
And finally, not all pups survive to breeding age in the wild. Now, this can be due to disease or aggression or starvation, for example.
So Alex and I gathered some estimates for these factors. So we estimated that the average lifespan is 6 years and the average breeding age is 2 years.
And a litter size of 6, where 33% survive to breeding age.
So we took this information and made a tree chart for the first 10 generations of offspring from a single female wolf.
We took that simulation data and we used a spreadsheet to draw the quadratic equation that would estimate the population.
But this is just a theoretical model. If we were actually starting a recovery program, then we would start testing our hypothesis using actual data.
In this case, the U.S. Fish and Wildlife Service has been tracking the population of the northern Rocky Mountain gray wolf since reintroduction.
And we use that experimental data and a spreadsheet to make a quadratic equation to match the population.
Now, the 2 curves are similar, but it's hard to tell looking at them separately. So let's superimpose the graphs atop each other so we can compare them.
Now, from this comparison graph, we can see that our simulated data is actually higher than our observed data.
But the graphs are similar. So now we just need to revisit our assumptions and revise our hypotheses.
Yeah, but it could be that we're just missing some important information, like maybe one of the offspring traveled far away from the experimental area.
It could be that our data is just too optimistic. For example, maybe one of the pups that reached breeding age didn't actually have offspring of his own.
This is what field researchers have been doing in the Rocky Mountains since they introduced the wolf packs in 1986.
Researchers are still collecting data, analyzing it, and revising their theories about recovery efforts.
The information is reported to Congress and other scientists to make sure that the program is working as planned.
And the data will be used to help recovering wolf populations across the country, from the Southwest to the Western Great Lakes.
You can find out more about wolf recovery at the U.S. Fish and Wildlife website at fws.gov.
Oh, those wolves, they are so beautiful. I wish we could go out and see them.
Yeah, they're certainly pretty, but I don't know, I wouldn't want to get too close to them. I would much prefer to use powerful binoculars.
What he said.